My Fosai research today, I will be doing, well, not a paper, but more like a general idea. You can kind of base this off like Feynman's path integral PhD paper if you want, but I shall be talking about the principle of least action, which you are a physicist, so you should know, but whatever. So supposedly we have anything at this point, right? And you want to go here. How would you know which path you were going to go? I mean, obviously you can use like the more analytical mechanics, Lagrange portrayal of things, such as you can envision force as like energy subtraction between like potential and kinetic, or kinetic and potential, which one of it was, I don't remember, and take the derivative of that, and at some point you can have like a minima, right? Like a physical minima, because you can just add, and by summing out all the every single point in the path, you have a minima. So by having that minima, you can do a Taylor expansion around it, like differentiate it, and like you can get something of it. So, which is pretty awesome, and that's kind of like a really beautiful way of observing reality if you want to observe it that way, or you can just look at it as a really beautiful tool. But supposedly you have some point here and you want to go here or something, and like you can go here, here, here. Which one would it go? It would choose the one with like the least action, which is the integral of like some like the energy, potential energy, kinetic energy minus each other. You sum up each point in the path, and like the one with the least one gives you an answer. I could really like this idea, even though it's not really one paper, due to how like kind of deterministic it makes life feel sometimes. It's pretty fucking cool. Excuse my swearing. And that's pretty awesome. And I also want to base it around like Feynman's paper. So the path integral, right, which is like EI something, and then the integral over that. Suppose you have a ball, you have a point here, like which way does it go? Like which way, like how do you know which path will it go? Well, based on principle of least action, you kind of would know anyways, because supposedly you have like all the forces going out from this piece of matter or like a particle. It would go to the one with the least action because every other one would cancel out, so you can kind of know what's up. But also, I think how, because I recently been like kind of reading a bit of physics, kind of, well, not really, more like watching physics videos and reading manifold learning based things, so differential things are kind of in my brain. But yeah, you can just look at it like like as a model of like, okay, like Feynman does. So like, okay, you have your ball here around your particle, like it goes in the one with like the least action, which like number of like the path to here to here. It's like the lowest integral of that difference between kinetic and potential, and you're happy. It's kind of weird, like how particles choose a path before it even embarks on that path. Like, sure, it's kind of common. It's something that happens in real life, in every life, and for most objects. And obviously, you can derive f equals ma from that, and derive that from f equals ma. Like, but you know, obviously, f equals ma. A is a vector. You don't really know what the vectors all the time, which is kind of annoying sometimes. So, just using that is pretty awesome. So yeah, I think physics as a mathematical model descriptor of the world can be, well, stylistic if you want to put it that way, because I did read like Surely You're Joking, Mr. Feynman, even though it's not really written by him. But yeah, I really like how it's like written like that, and like life is somewhat deterministic, but also it's kind of beautiful on like how life matters kind of has like things pre-planned out already, which is pretty awesome in my opinion. It's a pretty awesome thing. I mean, I wish I could write stuff, but yeah. That's about it. That's my short video presentation on principle of least action, which is how a particle takes the path of the least action, even though it doesn't really see in the future. It just kind of knows, like it heuristically chooses a path anyway, which is pretty awesome, weird, fucked up conceptually, but also really cool. Physically, it's cool. I wish you studied more of it.